in some of the earlier videos, we talked about the binomial expansion. So now that we have an understanding of the binomial expansion, we can now try to understand this. Why is it that when you try to differentiate this, the n here goes down, and then the n itself gets minus by 1? Okay, so now that we have an understanding of the binomial expansion, we can use that to try and understand this. But remember, the binomial expansion only works when n is 1, 2, 3, 4, and so on. It only works for positive whole numbers. So in the cases of when you try and differentiate x to the power of, let's say, 3 over 7 here, this video doesn't really explain why this gets minus by 1. It only explains when n is like a whole number. Okay, so in the cases of n to the power of 3.1732 whatever, this video does not explain this or this. It only explains when n is a whole positive number. Okay, so and the reason for that is because of this here. When we try to expand this, the binomial expansion only works for n when n is a positive whole number. So in the case of minus 3, the binomial expansion will not explain for the case of x equals x to the power of minus 3. This here you have to wait for another video. This here you have to wait for another video. This here you might have to wait for another video. Okay, but in this video, it will only explain for when x to the power of a whole positive whole number. Okay, so if you try, remember, whenever we want to differentiate something, we would take the limit of the x to the x plus a small amount, which is x plus h, and then power it to the n, and then take away the original, which is x to the power of n, and then divide it by h, and then make h tends to 0. So to find out the derivative of this here, we will have to perform this. Now the hard part here is this bit here. In the past, if you try and do this bit by hand, it takes a long time. So we would have to use a binomial expansion, and in several of the early videos, we developed a way of expanding this here. So when you expand this here, it will give you this whole thing here. Okay, hang on. It will give you this whole thing here. And then this x here, this x to the power of n here, is this thing here. Okay, so when you try to expand this, it then becomes this. So when you try and expand this, your first term will be x to the power of n. That's your and the coefficient is 1, but we don't bother putting the 1 in there. And then the next term, remember the x to the power of n here gets minus by 1. Okay, and then the h increased by 1. Okay, and then this and then you have a coefficient here in front of it, but we need a calculator for this. Okay, and then the next term will be, well, the previous term is n minus 1, so now you've got x to the power of n minus 2. So the x goes down by 1, and then the h goes up by 1. So now you've got h squared, as opposed to over here. Here you've got x to the power of 1. Here you've got h squared here. And then here you will also have a magical coefficient, which we will need a calculator for. Okay, and then so on, dot dot dot, and then your second to last term will be this. Your second to last term, well, you know the last term will be h to the power of n. So the second to last term will be h to the power of n minus 1. Okay, and then don't forget you're going to have x to the power of 1. You still got 1x left, and then the coefficient here, whatever it is, we're going to leave it to our calculator. Okay, and then the very last term will be h to the power of n, and the coefficient of that will be 1, just like the coefficient of over here will be 1. Okay, so this whole thing here will be this here. Okay, now if you don't understand this bit here, how to get from here to here, then you have to watch several of the earlier videos, and then this here becomes this. Okay, so now we can cancel this out. This cancels out with this. Okay, that will give you that will give you this here. Okay, so cancel these two. Okay, kill off this and kill off this. That will then leave you the rest here. Okay, so this is the rest, and then now divide top and bottom here by h. So whenever you have a fraction, you're allowed to divide top and bottom by the same thing. So now when you divide, divide top and bottom by h. So this divided by h, then the whole thing here would be 1. Okay, and then looking at this first term here, when you divide this by h here, so when you have this divided by h, the h goes because you've only got this times an h here. So when you divide it by h, the h gets killed off, leaving you just this bit here. Okay, so when you remember that when you divide top and bottom by h, you've got to divide every term by h. So at the top you've got to divide this by h, you've got to divide this by h, and then there's lots in between, and then the second to last term you've got to divide by h. This here you had to divide by h. When you get this divided by h, you will get this. So it's basically the h goes, and then here because you've got h squared here. Here because you've got h squared here. When you divide this whole term here by h, divided by h, then you're only going to get one h left, because when you have blah 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 h squared divided by h, then you're just going to get blah 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 h. Okay, because it gets killed off. So my point is that when you get this term divided by h, you're going to get this. And then lots happens in between, which we don't care about. And then the second to last term here. So at the moment you've got h, second to last term, you've got h minus h to the power of n minus 1. When you divide, so it's blah 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 times h to the minus 1. And then when you divide it by h here, then the answer will be blah 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 h n minus 2. That so when you divide this term by h, you're going to get this. So h to the power of n minus 2. And then the last term here, at the moment you've got h to the power of n. So when you divide it by h again, you're just going to get h to the power of n minus 1, which is this term here. Okay, so this whole thing here becomes this here. It's just us simplifying it. So what we've done from here is that we divide top and bottom by h, and then that would take us to this. Okay, now so whenever you have a block here divided by 1, it basically becomes that block. Okay, so when you divide it by 1, this whole thing here becomes this. Okay, now take the limit as h tends to 0. You see, as h tends to 0, this thing here is going to head towards 0. So eventually you're going to get 0, near 0. You're going to get 0.0000001 times this thing here. So the limit as h tends to 0, this whole thing here will become 0, because in effect this thing here is going to in a way it becomes 0 times this thing here. So you're going to get 0 here, and then you got h here as h tends to 0. This term here goes as h tends to 0. This term here goes, and then everything else in between will contain h. So they're all going to go. So all that you're left with is this, because this term here does not contain h. When you try to take the limit as h tends to 0, this term here doesn't contain h. All the rest do. So they will eventually tend to 0. So when you take the limit of this whole thing here, it basically becomes this, which is just this block here. Okay, so that's all that's left. Now remember, when you have remember that this thing here is in a way this thing here. Okay, so you can now put this into here. So this here is this, and then this here is this. Now here you got n and then 1. So remember this thing here. This n here is this here, and then 1. Well, and then 1 here would be would be your k here. So basically, we are going to put this thing here into this thing here. So it basically becomes this and times this here. Okay, and this bit here, when, well, 1 factorial is really 1, so we can pretty much forget about this. Okay, because, hang on, so we got to this stage here. Okay, now this thing here becomes this. It's nice and simple because this thing here, 1 factorial is just 1, so we can pretty much forget about this. And then now we've got n factorial divided by n minus 1 factorial. Well, that's like this. That's like this. Hang on. That's like 5. Remember, so you got n factorial divided by 1 less factorial. Now, so here, if you look at 5, 5 factorial would be this. 1 less factorial would be this here. So notice that this will get cancelled out with this. So these two goes, and that will just leave you n. Basically, this whole thing here will leave you with n. Because whenever you have n factorial and then you divide it by 1 less factorial, then the tail end of the thing gets killed off. So it's just like this here. 7 factorial 7 factorial divided by n minus 1 factorial. That's just like 7 times 6 times 5 and so on, and then divided by this, then you can see that this gets cancelled out with this. So all that you're left with is the 7. So my point is that this here looks complicated, but we can forget about 1 factorial. Now, whenever you have n factorial divided by n minus 1 factorial, all that you're left with is really n. Okay, so this whole thing here is really n. So the whole thing here becomes n to the power of n x and then to the power of n minus 1. That's why when you differentiate the whole thing, it becomes this. Because this thing here is really in effect n. Okay, and remember that this proof here only works for when you're trying to differentiate x to the power of n, where n is a whole positive number. It doesn't really prove it for the case of I don't know, x to the power of pi or x to the power of 3 over 7. It only works for x to the power of n, where n is a positive whole number. Okay.